Happy noon, guys. Let us go for cyclic structure of glucose. Cyclic structure of glucose. So this is a normal structure, you know that. That is C double bond of H, 2, 3, 4, 5, 6, CH2OH, OH, 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 and remaining, let me fill with hydrogens. Okay. Now this is a structure you know. After going through series of reactions, we had obtained the structure of glucose is like this. This is a structure. This is a linear structure, right? So whether there is a linear structure, there is a linear structure. Even though what is the need of cyclic structure? The reason is stability. Stability in the sense the cyclic structure are more stable than the linear structure, right? Before getting into the cyclic structure, let us get into the concept, that is hemiacetal concept. Hemiacetal concept, right? Listen carefully. This is most important to understand the remaining structure of this glucose. That is, consider an aldehyde. This is an aldehyde, right? RCH is an aldehyde. When it reacts with an alcohol, ROH, the oxygen will be having lone pair of electrons, right? So this carbonyl carbon is semi-negative in nature, sorry, semi-positive. This carbonyl carbon is semi-positive in nature because of the high electronegativity of this oxygen. So the oxygen from the alcohol donates its lone pair of electron to the carbonyl carbon. Then this oxygen takes away its electron and acquires a negative charge. So the structure will be C single bond O minus because it acquired the electrons, and here O is bonded with a positive charge because it has given the electron, so it acquires a positive charge, and R dash will be there, and hydrogen is also will be there. And here in this carbon there is one hydrogen, there is one alkyl group. To differentiate these two alkyl group, I mentioned this alkyl group as R dash, alkyl group. In that, what is that? Alcohol, I am mentioning this as R dash, right? Now what happens? Positive charge means you know that there is a thirst for electrons. So it pulls the electron from the hydrogen. It pulls the electrons from the hydrogen. That is a oxygen pulls out the electron from the hydrogen and releases the hydrogen as H plus. So this H plus goes and makes bond with H minus. So the structure will be COH, OR dash, R and H. So this form is called as hemiacetal form. This form is called as a hemiacetal form. Let me tell you one more time. So what happens here when the oxygen donates a lone pair of electrons to the carbonyl carbon, the double bonded oxygen pulls away its electrons, so it acquires a negative charge, and this oxygen acquires a positive charge. That is, alcoholic oxygen acquires a positive charge because it donates its pair of electron to the carbonyl carbon. So in order to quench the thirst, this positively charged oxygen pulls the electron between the oxygen hydrogen bonding and releases a hydrogen devoid of electrons as H plus. This H plus goes in contact with the O minus, and it forms bond there. So the positive charge of the oxygen has been quenched. Now we can get the hemiacetal structure, right? Now I am going to apply the same concept to the glucose. Let me draw the structure of glucose here. That is C double bond OH, 2, 3, 4, 5, 6 CH2OH. Listen here. Now let me write like this: OH, OH, H, H, this is also CH2OH, here H, here OH. This is the structure of glucose, right? Now what happens? The second last carbon, the second last carbon, the oxygen bonded to the second last carbon, it donates its lone pair of electron to the carbonyl carbon, right? And the reaction takes place. What reaction takes place? So that this oxygen pulls away its electron over, it acquires a negative charge, right? The oxygen has given out its two electrons there, so that it acquires a positive charge. To quench the positive charge, it pulls away the electron from the hydrogen and drives hydrogen away as H plus. So this H plus goes in contact with this O minus and OH will be formed. So we can have the structure COH, H, COH, H. Again, the remaining will be same as it is. Isn't it? Yes, the remaining will be same as it is. Yes, here C H O H C O H H. The fifth carbon atom has taken part in the reaction, so that the fifth carbon atom only has given its electron to the carbonyl carbon. So it will be bonded like this and H CH2OH. So this is the final cyclic structure, right? So listen here. Now you have a question in your mind. Why the last second carbon atom has given its electron? The oxygen, the last second carbon, why it's given its electron to the carbonyl carbon? Why not the last one? Why not the previous one? Now, the answer for this question is it form a five-membered ring so that it is more stable. So to form a ring, if we get the electron from this carbon atom, the ring will be more stable, right? So let me draw the structure in the cyclic manner. I mean the ring form. This is cyclic structure. Let me draw it in the ring form. Listen here. I'm drawing here like this. This is a six-membered ring. And I'm mentioning the oxygen here. So this is oxygen here, right? This is oxygen here. Now, what we have to understand, the group which is present in the right hand side should be written below the plane, right? Should be written below the plane. Now, I am coming from the first carbon atom clockwise. This is first carbon atom, second, third, fourth, fifth, and sixth carbon atom. So this is the first carbon atom here, second carbon atom, third carbon atom, fourth carbon atom, fifth carbon atom. To this, the sixth carbon atom will be attached. Sixth carbon atom will be there. Okay. Now, the first carbon atom, that is OH is on right hand side. So this is on right hand side. So let me write the OH downwards, H. And the second carbon atom also the OH is on right hand side. Let me write the OH downwards and H. In third carbon atom the OH in left hand side. So I'm writing upwards, H. And in fourth carbon atom the OH is on right hand side. So I'm downwards, H. And in fifth carbon atom, the CH2OH should be written on the fifth carbon atom. So it should be written on the top. The CH2OH is written on the top. And one more side, hydrogen is there. That should be written on the bottom side. So this is a cyclic structure. This is a ring structure of glucose. And this is more stable. This is more stable if we got the electron from the C5 atom, if you got the electrons from the C5 atom, right? That is why the electron from the C5 has been given. This is a, we can call it as a five-membered ring because oxygen is attached here, so we cannot call it a six-membered ring. It is a five-membered ring. The five-membered ring will be stable, so that to attain stability, the carbonyl carbon is getting electron from the fifth carbon atom. Is it clear? Let me tell you again one more time. What happens? The fifth carbonyl carbon, the oxygen attached to the fifth carbonyl carbon donates its electron to the carbonyl carbon. It's not, let me tell you again, the fifth carbon atom, the oxygen attached to the fifth carbon atom donates its electron to the carbonyl carbon so that the unwanted oxygen taken away takes back its electrons and acquires a negative charge. And here, this this oxygen has donated the lone pair of electrons so that it acquire a positive charge. So in order to neutralize itself, what happens? It pulls the electron from the hydrogen and gives a hydrogen as and releases the hydrogen as H plus. This H plus go on makes bond with the O minus, so we can get the final structure like this. This is a cyclic structure. If we write the same structure in a ring manner, so the ring is like this, and the point we have to note down here is the right hand side. The groups which are on the right hand side should be written below the plane, below the plane, right? So this is I think this is the end of the structure. So if you have any doubts, just text in comment. Let me clarify instant. Thank you.